Good evening. Thanks for coming. So we talked a little bit already about serverless, but I'll do a sort of fast introduction, and then after the filming section, we can get into some code if you want to see some stuff, because we built a couple of things recently with serverless, which is where some of this stuff comes from. Okay, so to dive right in, if my clicker works. Okay, so we talked already a little bit about like what is serverless, right? And it's a bit confusing. So serverless is several things. It's a term, right? It's a word that describes an architecture pattern, but it is also, confusingly, a framework. So if you go to serverless.com, you will find the serverless framework, which is shipped through NPM, and which is all about JavaScript, right? But serverless as a pattern isn't only about JavaScript. The serverless.com framework has a shortcut SLS. So later I'll show some SLS commands, and that means it's specific to this. So the whole thing starts from this concept of functions as a service, right? That you can take a function and deploy it without any additional stuff. And it was not actually started by AWS, but AWS launched this service Lambda, which was not the first, but is arguably the most famous of the function as a service providers, right? Now there's a whole bunch of them. There's a free one from Auth0 that allows you to do a certain amount of stuff. You can run your own OpenWhisper type stuff with IBM and other frameworks. Google have their own offering, etc. And so the framework, AWS will allow you to run, AWS Lambda will allow you to run Node.js, so it supports JavaScript functions on the server. You can run Python, Java, C#, with the .NET, something or other, I don't know, and Go. So those are the languages that it supports directly. But tonight we're going to speak mostly about JavaScript, because that is the framework and our personal sphere of experience. Okay, so what does this whole thing actually mean? The first thing to kind of walk through is the execution model. And if you're familiar with the LAMP stack, you were talking about PHP, then in many ways, I think about the whole serverless architecture conceptually like PHP, like Apache paired with PHP specifically. So Apache receives an inbound request. It takes that request, does some parsing, figures out what parses the body, reads out the different parameters, gets the URL, blah, blah, blah. It also then will run some routing, right? Apache will do routing for you and figure out which PHP file your request should land on. Then it will start a process that will run PHP, right? So your PHP application gets run on a per request basis. So one request equals one process. And importantly, it runs to exit, right? Which is very different than, say, writing a web server in Node.js or in Go, where you have a single server that runs continuously serving multiple requests, right? Whereas in the serverless paradigm, like with PHP and Apache, you have one request and it runs through and then it exits. And so you can sort of conceptually model this, like the request comes in, hits your function. I guess there was supposed to be a slide earlier that talked about statelessness, but it's probably going to come later. And because your function is stateless, you need, if you want to do anything beyond just process the input that you got, you probably have to talk to some kind of backing store or database or whatever. In fact, these slides are definitely out of sync because I do not understand what this is talking about. Okay. So what does it mean? So that's the execution model, right? It's quite different. It's a bit like, I really think of it like PHP. And there's a lot of nice things about PHP. I mean, I'll come on some of the advantages later. But that execution model of like one request running to completion is very clean and simple and easy to conceptualize. So a fundamental thing about serverless is the pricing, right? So you pay per execution. And you pay in units of time multiplied by memory usage, or memory allocation, right? So it's about how much you allocate. AWS Lambda, for example, rounds to the nearest 100 milliseconds, or seals to the nearest 100 milliseconds. So you can provision in units of 60 megabytes of RAM, and you get billed per 100 milliseconds of execution time. You have no requests, there is no cost, right? So fundamentally, it's quite a different model in terms of billing from traditional renting servers by the month, by the hour, even AWS, those sort of renting servers by the hour. It's still very different in the sense that you just pay when a request comes in and you don't pay when the infrastructure is sitting there doing nothing. I'm not 100% sure if that's true with Lambda. Maybe you pay something for the functions. I'm not sure. Another significant change is deployment, right? Because it's not like with PHP where you sort of FTP files to a server and all this stuff. All you can deploy are functions. It doesn't matter which language you're using, you have functions. And so you upload your code, you upload the code to whatever, in whatever language you're using, and you might do that with the serverless command line tool. It makes all that whole thing much easier. And then effectively what it does is takes your JavaScript code, uploads it to Lambda, and then Lambda takes care of the rest. And you can go in the like SLS will also wrap sort of Webpack and Babel and a bunch of other things. But you can open your function in the AWS console and see the code, right? Because you just upload code for a specific function. Stateless, that's what I was looking at earlier. So this can be a blessing and a curse. PHP is not strictly stateless in that they have sessions and stuff like that. But the idea is that when your function runs until it exits, once it is exit, your entire environment is reset, right? So you don't have any issue with like shared globals and stuff like that. And this is very different to traditionally writing a web server with Node. Like traditionally with Node, you have these globals, right? Whereas with serverless, you don't have any globals. And because of the way that JavaScript passes all objects by reference and so on, it can get quite complicated conceptually to have to remember that your server may at any given time be processing multiple requests in parallel. And with Node, you don't often have to think about it the way that, because of the way that the event loop works and so on. But you have all this shared state, and you have to be quite careful that you don't pollute the state of other requests by mutating variables which are actually for a different request, and then people are getting the wrong answers and so on. So with a serverless approach, your functions are stateless, and therefore it's fairly straightforward. So that's a little sort of scratch the surface in terms of how it works or the basic pattern. So then why would you want to use serverless, right? When does serverless make sense? And one of the main drivers can be cost. Because it's a very different pricing model, it can be cheaper, right? But that's not always the case. So fundamentally, if you have infrequent loads, so if you have infrequent requests, or if you have like intermittent requests. So if you have things where you have a flurry of activity at a specific time, but the rest of the time your servers would be sitting idle, then it might be advantageous from a purely cost perspective. But it's not 100% true, right? Obviously, you pay more per unit of execution than you would if you bought the entire server. So another big aspect of serverless is you don't have any servers, right? Which is not strictly 100% true in the literal sense. But the key thing is you don't have to provision servers and you don't have to manage servers. And there's always cost, complexity, time, headaches, pagers, midnight wake-ups, etc. Monitoring, all kinds of complexity that comes from provisioning and managing servers. And in some ways you can outsource all of that to some kind of AWS provider. Obviously, if you're using some kind of open source thing like you're talking about with Kubernetes and running it all yourself, then this is not true. Then you're still responsible for managing all the infrastructure. And again, like there can be advantages at scale, but again, only if you're using a commercial provider. If you're running this yourself, the scale angle isn't really going to help you because you're fundamentally just renting servers and running your own functions on them. But if you use something like AWS Lambda, then because your functions are stateless, they can, in theory, scale horizontally, right? So many requests come in at the same time. You can boot many different containers to respond to those requests. And in theory, you have this elegantly, infinitely, horizontally scalable system. Obviously, in practice, there are constraints, like whatever backend services you're using and so on and so on. So when I was doing a bit of research today, reading one of Martin Fowler's posts, I was surprised to see that one of the stated advantages of serverless is that it can be more green. Never thought about that. There's this whole thing where they were like, there was a search engine that was like Google, but just with a black background. And they were arguing that that would save money and save energy and save the planet and so on. I'm not personally sure if that's true, right? As I understand it, the LEDs, like there's a backlight and there's an LED, and the backlight's on all the time, whether you're showing black or whether you're showing color. So I'm not sure it really saves any energy. But anyway, you're obviously not paying to run servers which are sitting idle, and therefore they're not consuming electricity while they're sitting idle. And so in theory, you get a slightly more efficient resource allocation. You know, you can handle, give a greater workload with the same amount of electricity. So there's an interesting concept. And then because all you're writing is functions, so there are some testing advantages, right? All you write are functions. So you just create functions, and those functions get wired up to respond to incoming requests. So you can write unit tests across your entire stack very easily because all you do is create functions, right? So for unit testing, it can be easier with a serverless approach. So then on the flip side, why would you not want to use it? Like, what are the disadvantages? Those are some of the advantages. And again, the first one is the same, cost. Like, if you have a consistent level of demand, it will be more expensive because you're paying more per 100 milliseconds of execution time than if you rented the server for the entire month. And like with AWS, if you pre-provision a server for 3 years, like if you pay in advance or you commit to buy it for 3 years, you get a significant cost saving. And so servers on demand, or like compute on demand in this way, it's always more expensive for the marginal unit of cost or the marginal unit of compute power. And so it really depends on the shape of your load. One of the nice things with, for example, Lambda is they have a pretty generous free tier. So we've deployed some stuff, like I'm always thinking about longevity. And so we'll build some small projects for hackathons or for this or that. And I'm a big fan, for example, of using WordPress.com. Because you just put, if you just want to create content and you're not trying to commercialize it, you put it on WordPress.com, and 2 years later when you decide, you know, I don't need to renew the domain name for that project because actually this hackathon thing that I did 3 years ago, I don't need to keep spending $10 a year. The content lives on, right? And so there's a similar kind of thing here. Like I've deployed some stuff to serverless that gets very little traffic, but I like the idea that it's going to live on there for a long time because the marginal cost is extremely low, right? But yeah, if you're doing something more traditional, like where you have a more traditional, where you have like a higher level of continuous load, then it's almost certainly going to be more expensive. Another significant downside is the startup time. There can be a significant delay between, so this is on a cold start. So if a request comes in and you have not had any requests recently, then there will be some kind of delay. If you're running Node on Lambda, it'll be between 10 and 100 milliseconds. If you have like less than 1,000 lines of code. So if you have a fairly simple application with a limited amount of code, then it will have a fairly quick cold boot time. But apparently if you're running something like Java on top of some complex JVM, blah, 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 you can see initial load times of up to 10 seconds. And so this can be significant. If you're building things that need to be responsive, then people end up writing additional services to periodically ping their serverless services in order to keep the caches warm, to keep the whole thing live on Lambda, right? And this makes some kind of sense if you think about the model of how it works. Like your functional code gets put into some kind of permanent storage inside of AWS, so it's probably stored in S3. A request comes in, if that code is not currently running on a container, AWS needs to provision the container, go fetch the function, put that function, all that code inside of the container, then wire it all up, and finally deliver your request to the function. So all of that stuff takes time. Like if you make the second request, it'll be much, much faster because they leave the containers there, assuming that they have sufficient capacity, right? So this cold boot time can be significant, again, depending on the use case, but it's something to be aware of. Another thing is that there are some hard limits. and there isn't a practical way to work around them. So for example, with AWS, you have a maximum execution time of 300 seconds. So if you want to do something that's going to take more than 5 minutes, some kind of process, if you want to do video transcoding or some kind of intensive work, then there isn't a practical way to do that on AWS Lambda, unless you can sort of persist it somehow and then resume it later, right? But all that complexity is probably going to be more effort than it's worth. Also, Lambda has a maximum memory allocation of 3 gigabytes, 3008 megabytes to be precise. And so again, if you want to do something like highly memory intensive, then this might not work, right? There's going to be a problem. So we talked already about statelessness. Statelessness can be an advantage. It keeps things simple, keeps things clean. It's a simpler paradigm. But at the same time, every time you have to make a request or go somewhere else to get some kind of persistent data, that is very slow, right? So there are other times when you want to have state between requests where it makes things easier or more efficient. And then already we talked about testing. So while you can do unit testing very easily because all you have are functions, if you want to do integration testing, it can be much more difficult, right? Because you have a lot of complicated moving parts which are outside of your control. And then one of the main points from my personal experience with serverless, the framework and the whole approach in general, is the developer experience. The developer experience is definitely not awesome. Like compared to, for example, running PHP or the LAMP stack on your local development machine, you can pretty closely emulate production, and it's a very well understood pattern, and you can just deploy the thing very easily. The developer experience with serverless was not, it was definitely not awesome. So this is talking about SLS, the framework. And to be fair, the serverless framework, I absolutely believe, makes this probably 10 times easier than using the underlying services directly. So this is already doing like a lot of the donkey work, a lot of the legwork for me. So the first thing is like trying to run these functions locally is difficult. The SLS tool does not directly support a mirror image of what this will look like in production. So I was deploying to AWS, and I'll come back to that in a second because I have a slide later that helps. And the other thing that was just super difficult was debugging. Like, it was very difficult for me to see inside of the request as it was going through. And in part, that's because when I walked through the stages earlier, there was a step missing. It's not just request to function to database. At least with AWS and with most of these providers, there's a layer in the middle, which in the case of AWS, they call the API service or something. So a request comes in, the HTTP request is terminated, understood, processed, and parsed by an API service, which in turn forwards that to your stateless function. So the function gets invoked not with, like, it doesn't actually read the incoming HTTP request. It gets invoked with a whole bunch of context variables, all kinds of additional information, which when I was running it locally, I was not able to replicate. And I tried a bit. I didn't try super hard, but I spent some time trying to get it to run locally on my development machine as it would do when it was actually deployed, and it just didn't work. The whole thing, my experience was that the whole thing was super opaque. Like, there was just this black box of magic going on, and I had no idea how to understand what it was going to do. Like, I was trying to do simple things like read the incoming request body and parse it as JSON, and that was turning out to be a nightmare. Now, admittedly, I was playing around with TypeScript, and I was trying to do a bunch of different things at once. I was trying to ignore the walkthrough and say, well, I don't want to use that. I'm going to use a different web server. I'm going to use Koa, and I'm going to wire it up, and blah, blah, blah. But the whole thing was just difficult because it's not like a simple request. You know, you're not writing an HTTP server. You're writing something that responds to function calls which are generated by some service that terminates HTTP requests. And that's quite specific. So what I ended up doing in practice was just deploying a lot and adding a lot of console logs. It took me a while before I eventually figured out there was a logs command, so the serverless framework will pull the logs for you. And I just ended up using a lot of console logs, deploying a lot, and making test requests. And even making the test request was difficult enough because I was trying to get a JSON body, which was coming from I was trying to build some middleware between two services. Like I was building a chatbot, which you can see on our website today. It's going to go down fairly soon. But if you go to our website, you have this automated interaction where it starts talking to you, and all of that is serverless functions. Also, I hit things like the execution time limit. So by default, if you don't change it, your functions will time out after 5 seconds or something. So you need to sort of extend that. There's just a bunch of things that I had to understand, which I didn't know previously from either PHP, Node.js, or whatever. So yeah, I would say the developer experience today is definitely not great. One of the other major downsides is that you're super tied into a specific vendor, right? And so a bunch of things come from that. So first of all, there's vendor lock-in. Like I was using the serverless framework, and it will deploy to a bunch of different backends, but they're all subtly different. So if you look at the serverless documentation, serverless.com documentation, as soon as you get past the npm install serverless, you start to get into everything else is underneath one provider. So if you want to read the CLI command line tool documentation, it is unique to each provider. So there is a documentation for the AWS command line versus the Open Whisper or whatever, I can't remember what it's called. And so in theory, these things should all be kind of, you can take your function and you can move it and you can run it anywhere, but in reality, the specifics of that are non-trivial. And so your functions are not like super, super portable. Serverless, the framework, is doing some interesting stuff where they have this kind of event system. As I understand it, the idea is that you can communicate cross-provider through a sort of standardized event system. So you can receive a request on AWS, you can trigger an email to be sent, and that email gets executed, that email send request gets executed in a different provider, like in a Google Compute function, for example. Never tried it, don't know anything about it, but it seems like an interesting idea. I think also that vendor lock-in thing is something, it's easy to underestimate at the beginning of a project and think, oh, it's not a big deal, like AWS has been around for a long time, blah, blah, blah. I mean, AWS and Lambda specifically are probably past the point of, like, I don't know if you remember parse.com. There was this service parse.com, which was like a backend as a service. So you could build your entire backend. It was acquired by Facebook, and then one day they put up an announcement, parse.com is closing down. You have a year, we're gonna open source a bunch of it, and then we're gone. And the day before that announcement came out, we had been considering whether we wanted to recommend Parse to a client. And then the following day, we read the announcement that says, Parse will no longer be accepting new customers. And so there's always this risk with if you're buying into highly proprietary technology, right? So if you're using some of the open source systems, it's different. And maybe you can buy them also hosted from IBM with the fallback on an open source, which might be interesting. But otherwise, you're pretty tied into that vendor. Like AWS's APIs are not mimicked anywhere else. As they change those APIs, if they have downtime, if they have outages, et cetera, et cetera, et cetera. So another potential risk is just the fact that you're dealing with a multi-tenancy system. So they're running your code alongside a bunch of other people's codes on the same bare metal hardware. And that introduces a bunch of risks. Again, it's tied to the vendor. So some vendors will do this very well, and some of them will have more problems. But there is the potential for your application to see things that another application is seeing, or vice versa. There's a whole bunch of security stuff, and this is kind of a hard problem to solve, and it's just being aware that there is some kind of risk involved. I would say that to summarize all that, you could put it all together and say that the technology is still fairly immature. And that's, it's a very interesting paradigm, and there's a lot of reasons going for it. And so some of the statelessness and stuff like that makes it very appealing. It's closer to the functional programming approach. It's a very nice concept, but it's still super immature. Like the tooling is pretty basic. The whole experience is still definitely not at the point where it's ready for sort of mass mainstream adoption. Everybody's going to be building serverless functions, et cetera, et cetera. To put that into context, like AWS Lambda launched in November 2014, right? So it's like 3 and a bit years old, 3.5 years almost. Serverless, the framework launched about a year later in October 2015. So we're still kind of in the early stages of this whole adventure. So the next thing I'm going to come on to is just a very fast run through of like how to get started and how to get some functions running. Any questions on what we have covered so far? Great.
No, actually, I could ask one.
Yes.
What about the database scale in the end? I mean, you will have some, you will need some resources that you can ask questions.
Sure.
I mean, even if your function is scaling horizontally, maybe the resources are not.
Yeah.
This imposes some interesting aspects.
Sure. Yeah, so the question is about horizontal scalability of the resources behind. Definitely. And if you use something like RDS from AWS, where you have this, you just buy fully managed containers that run a specific database, they absolutely have resource constraints. In theory, I don't know Google's product lineup so well, but with AWS, in theory, you can use a product like DynamoDB, where you don't provision resource in advance. You buy like a database API, and in theory, DynamoDB can scale with your kind of horizontally. I'm not familiar enough with DynamoDB to really know how it works. Like I know some of these services you pay for provisioned availability. So if you want to be able to do a lot more requests at once, you pay to have like 10 requests per second of provisioned capacity. And therefore, that sort of defeats the whole horizontally scalable point.
DynamoDB is a good example actually because this scales fluidly. Right? So RDS will scale only in steps and you have to take care of it. But DynamoDB just grows with you and it's getting really expensive then. But yeah.
But with DynamoDB, I think, don't you pay per provisioned, like like if you want to be able to do 5 requests per second, you pay less than if you want to be able to do 50 requests per second.
I think so, yeah. And they even pay different, or you pay differently for writes and reads.
Yeah.
And even then, I mean, if you exceed some certain amount of writes, you even pay more for this or less.
Yeah, and so that's like with DynamoDB specifically, I think it will scale horizontally, but you need to kind of provision in advance how much scale you want, and you pay based on how much you want as well as how much you actually use. That's my limited understanding.
Then it scales indefinitely. I mean, it can grow really huge, they say. I don't know.
But in theory, it scales indefinitely, and maybe it scales indefinitely in terms of data storage, but it probably doesn't scale that fast in terms of ability to access number of simultaneous requests. So, for example, I've been to Burning Man, and I go to a bunch of burner events, and there's always this thing with tickets, right? It's a super interesting technology problem. Like Burning Man, the year I went, the year after, there were 80,000 tickets, right? I got into the line, like there's a line online. I was in the line in the first like 3 or 4 seconds, and I did not get a ticket. So they sell 80,000 tickets in like 2 seconds or less, right? And of course, like Burning Man historically has had huge problems with service falling over, like, and there's a bunch of also regional events. Like I'm involved with some of the regional events here in Berlin, and they all, again, just huge problems, like database fail, like errors during ticket sales. And this is a very unique and very specific problem, which is kind of suited to this approach because you have a absolute shit ton of traffic at a very specific time. And so, like if you have some kind of system running with DynamoDB, for example, and you have a certain amount of write and read capacity provisioned, and you suddenly get this like vertical wall of mad scale, it's not obvious to me that DynamoDB will handle that gracefully, even if you have an Amex Black card with unlimited spend, right? Where you can like, burn as much money as you want. So yeah, like you definitely do not, it's not like this is some kind of silver bullet for scalability, for sure. It's just one part of the equation. I mean, maybe you can do stuff like you can queue things or you can kind of whatever. Yeah. Any other questions?
Is there a movement in the vendors itself to make it more interchangeable between the vendors, or are they happy to lock you in? Is there any things changed?
So the question is how are the vendors doing anything to support interoperability? I honestly don't know. My experience with AWS versus kind of Google Compute and so on, I would think that they're not doing anything at all. Because from a commercial point of view, if you have people locked into your platform, it's probably better, at least in the short term.
What does the login mean then? I mean, you have a function, this is Python or Java or whatever, and I mean, this is all obviously portable because it's just code. But what is not portable? Is there some context object that they're giving you and you can work on this one? This is maybe not portable, I guess.
Yeah, so what part's portable and what's not? So the way that the request arrives that gets delivered into your function varies subtly by platform. And that is not super straightforward. So because you don't parse an HTTP request, you kind of get this, like you have a function which gets invoked by the service. And so the way that they get invoked varies a little bit by provider. With AWS Lambda, for example, you can use console log and it's very easily and it all gets written out. I don't know how that works with other providers. I'm just guessing because I haven't tried other providers, but there are just subtle differences like that. So in theory, yes, your single function should in theory be able to be portable. But for example, the request body, you might get that in a different variable name on different providers, and it may be parsed differently. So on some it may be JSON decoded, on some it may not. And there's just little details like that where if you try to take a whole application and just deploy it to another provider, there are probably going to be problems. Yeah. Great. Okay, so how do you actually do this? This is going to be a very fast walkthrough, and then we can turn off the video. I can sit down, and then we can look at some code if you want to dig into it. Okay, so how do you start? The easiest way to get started is serverless.com. As a framework, it makes everything super easy. So I talked about the developer experience, but the developer experience here is still significantly ahead of doing this stuff yourself. So you go to serverless.com, you go to the Getting Started guide, and it will tell you to npm-g install serverless, and that's it. So you need to have Node and npm running on your machine. These are prerequisites, right? To get started, you do SLS create. SLS is the shorthand version of serverless. You can also type serverless if you like extra keystrokes. And then you need to pass minimum at least a couple of arguments. So the first thing is you give it a template, like in this case AWS Node.js, and that sets up your serverless project so that it will target AWS and it will use Node.js. For example, I think you have two choices of Node.js versions, but this is something where you don't have a lot of control. Node.js is provisioned, like the Node process is provisioned by AWS Lambda, and so you don't get a ton of options. Like you can't, for example, I don't think you can use Node 8, where the whole debugging experience has changed dramatically. Not that it really matters, I was not able to get any kind of debugging running locally, but whatever. So you give it a template, you give it a path, and then it just creates a folder called My Service. And inside of that, you get the basics. And there's a bunch of starters. You can use a bunch of different things like TypeScript and all kinds of other fancy stuff. And part of what the serverless command does is handle taking the kind of JavaScript that people write today and building it or transpiling it so that it can be run on the Node environment that is provided to you by AWS Lambda. Because it's not running Node 8, and therefore you can't use, and even Node 8 doesn't support all the latest and greatest features of Node.js and so on. So it's using Babel and blah, 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 and it deals with all of that for you. So I was able to, for example, build something with TypeScript, having no experience with TypeScript. I didn't have to run the TypeScript commands. It was all done for me by one command. You just type SLS deploy, and that's it. It gets shipped off. There is a config file which you have to edit, so you kind of tell it some information about what you want the route to be and so on. But by default, it will give you a route. You can just type this and you will get back a URL. You can hit that URL and your function will get invoked. And so this whole part is super, super straightforward. Obviously, you also have to authenticate with AWS to get this running. But mostly you could run all this in the free tier. Extremely useful. Took me a while to figure this out. SLS logs. It will fetch the logs from that function, right? So you can just do SLS logs. -F tells it the function name. So I think by default it's called hello. And then it will get it will just pull the logs from the server. If you add a -t at the end, like it will tail the thing and just pull them as they come in, right? And then inside of your code, you can just do console.log. So I don't know about other providers, but I know with AWS, this was super, super useful. And this is what I was talking about with the developer experience. What I ended up doing was a lot of console.log because I was trying to figure out, like, where is this stuff? I was trying to run it locally, and you can invoke your functions locally, but I was not able to invoke, like, when you invoke the function locally, you give it a context object. And I was not able to figure out how to pass a request body to the local context object. So I ended up just having to ship it all to AWS and then add a bunch of console logs to figure out what was going on. It was a pretty painful kind of, repeat experience to figure out where all the stuff was. Having said that, that's basically it, right? Like, you just SLS create, SLS deploy, it's up there, and then you also have an invoke, so there's an SLS invoke where you can invoke commands, but as soon as you run SLS deploy, you will get back a URL, and your function is live. And the nice thing is this command has done all the wiring up of AWS's API endpoint service, whatever it's called. It's wired that to your actual stateless function, and it's also provisioned it in an environment. So by default, I think the default will be sort of domain/dev/hello. The default is a hello world script. And it's already prefixed it with dev, so you can have different environments and you can deploy to different environments. I never got past dev. It worked. I don't know why I would have changed it, so I left it. And this is how we built, like, you can go and look at the chatbot on our website today. It's going down soon, but and it works, right? You send requests. It gets requests from an API. It figures out what to do, and it makes requests back. The nice thing is, because I built this super simple chatbot system, it's totally stateless. It doesn't require any external data store. It knows from the incoming request what it wants to do, and therefore it just executes a series of instructions. Like, what it does is just send responses. So a new user comes to the website, the chat process gets started automatically, the server receives a request that doesn't actually matter, it contains the conversation ID. Then the server starts sending responses. So you open the website and serverless is talking to you. Bang, message, bang, message, bang, message, bang. And then the last message is you get to respond. And if you click one of those responses, some additional metadata is passed back with that response that tells the script what to respond with. Conceptually, it's super simple, but it took me more than a day to get it running with serverless, right? Like, if I could have built the whole thing in, for example, we do a lot of work with Meteor, in way, way less time. The flip side is having to deploy Meteor somewhere is way more complicated, right? You need to run the node process. You probably want a process supervisor. It is going to have to run on its own port, so it needs to either be on a dedicated server, or you need to have some system of managing the mapping of domains to ports. Like, the whole deployment process with traditional Node or Python or whatever is super painful in comparison to this. Like, SLS deploy, I get a URL back, and I can just use that URL. And every time I do a deploy, that same URL gets updated with the new function. Any questions on this? Otherwise, we can jump into.
Can you use dependencies, like define something like package JSON and say, I want to use maybe the request library or something in your function?
Yeah, you can use dependencies. So you have the regular package.json thing.
It's deployed along with the SLS deploy then?
Yes. So when you run SLS deploy, it takes your application and builds it into a single file using sort of Babel and Webpack and all. I don't know if it's Webpack actually, but it transpiles it all. So if you open your built function on the console, it's this gigantic file that contains a ton of stuff. It's not minified though, so you can actually go through and read it. And all your dependencies are bundled in there. Yeah. I would assume that adding a lot of dependencies will slow down your cold boot time because you're increasing the size of your package. And like, for example, with Gatsby and Netlify, we were talking about that earlier, Netlify actually runs like the Yarn install process for you. In this case, that does not happen. So if you hack something inside of your node modules folder, that hacked version gets bundled and deployed to AWS as a part of this deployment process. And so, yeah, like you take the entire thing, compile it down to one single file, and ship that off to the server. There's also, to get this running with something like some kind of express type middleware, you need some kind of server. Like, for example, I was trying to use Koa. I couldn't get it to work in the end, so I just fell back on the default. But then you also need this special wrapper that takes a traditional Koa server and makes it compatible with AWS serverless. Because you're not getting an HTTP request, you're not listening on a port, a function is getting invoked, right? So that's a little bit different, but it's all part of the docs, and it's all set up as part of the template.
Well, you can do this in JavaScript, but if you try this in Go, I mean, you have to define dependency somehow. You want to use some cryptographic library or some mathematic library. There must be some way to declare dependencies. Or maybe there is no way. It's also possible. Yeah, in JavaScript it's easy. You just write everything in one file. In Go, I think this is getting...
I know, so how does that work in Go? So I know enough about Go to know that Go builds a single binary, all dependencies statically linked. So in the case of Go, I know the answer. That's very simple. Python, you make a good point. I don't know how Python dependencies are shipped, but I would assume, so I think the traditional way you pass stuff to Lambda, if you don't use the serverless library, is as a zip file. So I would assume that you build all your dependencies and then you take the entire thing as a zip and you ship it to the server. Because, I mean, you could do some kind of dynamic loading of dependencies. So for example, you could have some system that takes your dependencies, gets a package.json equivalent file, goes and fetches all those things from the web. But bearing in mind, you pay per millisecond of execution time. So that's going to be super slow. And you're going to have to do it every single request because your functions are stateless.
On deploy time, and then it's just, right. This could happen. I don't know.
I think, yeah, but that's the point. All of that stuff happens at deploy time. So the deploy process includes some kind of build. The thing is, if you're using Python, you need to use something which is not serverless.com. So I don't know what the frameworks to do that look like. You can also run arbitrary code via Node, right? So there are packages to run any language you want inside of AWS Lambda function, so long as you kind of can wrap it all up in the Node container and so on. I believe you can just deploy a zip file. I think that's the trick, is you can put arbitrary files on disk. Any other questions? Great.